Okay, so I went and just started a new video so I wouldn't have to go back and correct everything that I did on the next problem that needed to be on this problem. So we have 3 plus the absolute value of x. We created the v in our graph. I had just forgotten to fill out this table. So when I fill out the table, when x is -2, the y is 5. When x is -1, y is 4. When x is 0, y is 3. When x is 1, y is 4. And when x is 2, y is 5. Okay, let me take out these because I had accidentally done this with the last problem, which is why I went back and started this new video. So let me take these out real quick, start fresh. With this new problem. Okay, this one. Our new function is f of x equals negative x squared plus 3. So once again, we're going to create our f and f of x table and then graph it. This V shape that is on there is not right. I'm going to clear it here in just a second when we get to the graph. So let's look at this in our calculator. So go to your y equals, clear out the last graph, put in your new one. So negative x squared plus 3. Let's look at the graph. It is that parabola shape. It's upside down, but it is a parabola. Let's go to our table so we can finish the chart on the problem. Let's see what x's it wants me to use. Again, it's -2, -1, 0, 1, and 2 to complete our chart. So let's see, when x is -2, y is -1. When x is -1, y is 2. When x is 0, y is 3. 1, 2, and 2, -1. So let's go back to our homework and complete our table. So when x is -2, y is -1. When x is -1, y is 2. When x is 0, y is 3. When x is +1, y is 2. And when x is +2, the y is -1. So there is our table completed. Now we're going to click to enlarge the graph. And again, that one's completely wrong because that was the last problem. So remember what the shape of this one was. It was the upside down parabola. So we're going to choose this U shape. It's just going to be upside down. And plot any point. So the first point, I'll just plot that very top one, -2, -1. So to the left 2 and down 1. Then the next one is at -1, +2. So to the left 1 and up 2. Again, doesn't look like a parabola until you put that third point. So I'm going to do the 0, 3. And then save it. Now, on this next one, number 8. So it's asking me if this is the graph of a function. This is where you use the vertical line test. If you can touch the graph more than once with a vertical line. And remember, vertical lines are the ones that go straight up and down. And if you can touch the graph, which looks similar to this one, so here's what your graph looks like. I can draw a vertical line right here and touch it more than once. So if you can touch your graph more than once, then it is not the graph of a function. Okay, on this next problem, I did a very rough drawing of what is showing on the homework problem. The first question wants me to find f of 3. So if you are finding f of 3, what's inside the parentheses represents the x. So let's go find where the x coordinate is 3. So it's everywhere. If you are to the right 3, you are on that line. Where does it touch the graph? Touches it here. What is that particular point's y coordinate? 2. So f of 3 is going to be equal to 2. Now, on the next part, it's asking me what is the domain of this problem, or of this graph. Remember, domain is your x values, or how far left and right does this graph go? Because remember, this is your x-axis. Now, if you'll notice, look at this graph. This side is going up and to the right forever. Up and to the left, and the other side is going up and to the right. You're eventually going to cover all the way to the left and all the way to the right. So your domain is going to be all of the real numbers. Now, the next part of this question says, for what x values is f of x equal to 2? F of x is the same thing as saying y. So it wants to know what are the x's when the y is 2. So think about on your x-axis where the y is 2. Everywhere along this dashed red line, your y coordinate is going to be 2. So it's actually hitting the graph here. That one's x is 3. And then it hits the graph again right here, and that one's x is to the right 7. So your x's when the y is 2 are going to be 3, 7. And then the last part of this is talking about what is the range. And remember, the range is your y values. So if you'll notice, this graph comes in from the left until it gets to here. Then it stops, and then it goes back up. So it actually never goes below that point. So I need to know that point's y coordinate. Its y coordinate is 0. All of the other points on this V shape are above that 0. So your range is going to be y's are all greater than or equal to 0. So you would choose this C option because that's your greater than or equal to option. And then tell it greater than or equal to 0. On this next problem, it says to find the domain of the function. My function is g of x equals 7 over 1 minus 9x. Remember, when you have a function that has an x in its denominator, you're going to have a restriction on your domain. There's going to be at least one value that your denominator cannot be, because the denominator cannot equal 0. So whatever your denominator is, in this case it's 1 minus 9x, that cannot be equal to 0. Then I'll solve this for x. I'll get rid of the 1 by subtracting 1. So now negative 9x cannot equal 0 minus 1, which is negative 1, and then divide by negative 9 to cancel that. So x cannot equal, the negative over the negative makes it positive 1/9. So it cannot equal positive 1/9. All right, getting into our algebra of functions. This first part of this says f of x equals negative 7x plus 10. And your g function, so g of x equals x squared plus 12, and it wants me to find f of 2 plus g of 2. So I'm going to do these kind of like two separate problems. I'm going to find f of 2, and then I'm going to find g of 2. When I get done with each of those, I will just bring that plus down and add those two answers together. So what does f of 2 means? That kind of means I'm coming to my f function and I'm replacing its x with a 2. So I'll have negative 7 times 2 plus 10. You can put that straight in your calculator from here. So negative 14 plus 10, which gives me negative 4. Now, I'm going to find g of negative 2, which means go to your g function, or excuse me, g of 2, go to your g function and replace its x with a 2. So I'll have 2 squared plus 12. So 2 squared gives me 4, plus 12 gives me 16, and now I will bring down my plus, because now it wants me to add those two numbers together, and negative 4 plus 16 gives me 12. The next one, I have f of x equals negative 17x plus 19, and g of x equals x squared plus 5. And it wants me to find f of 4 over or divided by g of 4. So I'm actually going to work this one just like I worked the last one. I'm going to find f of 4. I'm going to find g of 4, and then I am going to divide those. So f of 4 means go to your f function, replace its x with a 4. So negative 17 times 4 plus 19, and I'll just put that straight in my calculator, negative 17 times, or open, 4, close, plus 19, and it gives me negative 49. And then I'm going to do the same thing over here. I'm going to go to my g function and replace its x with a 4. So I'll have 4 squared plus 5, which gives me 16 plus 5, which gives me 21. So now I'll bring this down, and it wants me to divide that. So if I go to my calculator to the home screen and I do that negative 49 divided by 21. So I just want to ensure that this is in its most simple terms. So I'm going to hit Math, Enter, Enter. That will tell me whether or not this is in its most simple terms. So negative 49 over 21, and then hit your math key, and then hit enter twice. Well, what this shows me is that that was not in its most simple form. So that actually reduces to negative 7/3. All right, on the next one, I've got f of x equals negative 3x plus 3, and g of x equals x squared plus 4. And it wants me to find f plus g of x. Now, I actually like to separate these out. F plus g of x can also be written as f of x plus g of x. So what is my f of x function? It's that function right there. So I have negative 3x plus 3. Now it wants me to add that to my g of x function, which is the x squared plus 4. Now, when we are typing this in, we want to make sure that we type the highest exponent first. That's going to be your leading term. So the highest exponent is this x squared. So that needs to be my first term. And then the exponents go down from there. So then I'll do my negative 3x. And then I notice that these terms are like terms, which means there's no reason to write 3 plus 4 when you can just write plus 7. So you'll have x squared minus 3x plus 7. So this next one, we are going to be subtracting functions. And you really have to be more careful when you are subtracting. So you have f of x equals negative 5x plus 2. And g of x equals x squared minus 2. And it wants me to find g minus f of x. So first things first, I'm going to write these out separately like I did on the last one. It's going to want me to find the g of x function minus the f of x function. So what is my g of x function? It's that x squared minus 2. Now it wants me to subtract my f of x function. That whole thing is the function. So I need to make sure that I put this, what I'm subtracting, in parentheses. So minus that negative 5x plus 2. Now, before I do anything else, I'm going to take care of this minus by distributing it to what I am subtracting. So I've got x squared minus 2. Now, when I distribute this negative, it's going to turn that into a plus 5x and then a negative 2. And then I'll combine my like terms, starting with the highest exponent, which is that squared. And there's only that one x squared. Then I'll move to my x's, and I only have that positive 5x. But I do notice that I have -2 minus 2, which gives me -4. So I've got x squared plus 5x minus 4. All right, for this next one, for the pair of functions, f of x and g of x. So my f of x function is 1 over x minus 6, and my g of x function is 10x to the third. And it wants to know what the domain of the sum of those functions would be, the difference between those functions, and the product of those functions. So what you're looking at actually is the original functions for any restrictions on the domain, which since I do in that first function, I have a denominator with an x in it. So that denominator, which is x minus 6, cannot equal 0. Solve that by adding the 6 to both sides. So x cannot equal 6. There's nothing else that's going to make this denominator a 0. So that's its only restriction. And when I look at the other function, it's a cubed function, so there is no restrictions on its domain. So what I have found here, x cannot equal 6, is going to help us with the sum, the difference, and the products domains. All of these are going to be the same. They are x can be a real number. And then include your restriction, and x cannot equal 6. That is what you are going to put on all of these. So on this first one, x is a real number, and you have to put this entire statement in the blank. X cannot equal 6. Oh, whoops. No, I didn't want to do that. Go back. So again, the domain of the difference. X is a real number and x cannot equal 6. And then the last part, again, the domain of the product would be x is a real number and x cannot equal 6. Now next. All right, when we get to this next problem, we are going to use this system of equations and actually make matrices. Remember, we solved these by creating matrix in our calculator and putting the coefficients of the left side of the equal sign in our matrix A, and then the last part on the right side of the equals we're going to put in our matrix B, just the numbers. So going across that first row for matrix A, all of those have a coefficient of 1. Second row will be 2, 5, 2. Third row, -1, 8, and -3. Then our matrix B is going to be the answer side. So -8, -28, and -20. So we're going to solve this using the matrix function of our calculator. So we want to store matrix A in our calculator. So second matrix, going over to edit. Now remember, the first thing you have to do is tell your matrix or tell your calculator how many places you need. So I have 3 rows and 3 columns. So that's what I need to tell the calculator that it's 3 by 3, and then I'll put in my entries. So 1 across the top row, second row is 2, 5, 2, third row, -1, 8, and -3. So there is my first matrix. Now I want to make matrix B. So second matrix, I'm still creating. Now I need to go down and create matrix B. So let's see how many rows. So remember, rows go across. So I had -8. Whoops, I messed that up. Hang on. I tried to be fancy and draw in rows. So -8, -28, and -20. So that has 3 rows and 1 column. So that's what we're going to tell our calculator. And then I'll enter those entries. So -8, -28, and -20. So now you want to do second quit to go to your home screen. You are going to want to put in matrix A to the -1 and then matrix B. So second matrix, the A that you have stored in there is what you want to use. So enter, then hit the X to the -1 button to get that little -1 exponent, and then you want matrix B. So second matrix down to B. Enter. 0, -4, -4 are your X, Y, and Z. So 0, 4, and -4. All right, this next problem, same kind of thing. We're going to do matrix A from the left side of the equals, which are going to give me across the top row 4, 3, and 1. The second row is 1, -3, and 2. And the bottom row is 11, -2, and 3. And then we'll create matrix B that has the answer side. So 24, -7, and 35. So we are going to put these in our calculator by using the matrix and edit. So second matrix, over to edit, because I want to put in my new numbers. It is still a 3 by 3. So let's put in our new top row, which is 4, 3, 1. Our second row is 1, -3, 2. And our bottom row is 11, -2, and 3. So there's matrix A. Now we want to put in matrix B. So second matrix, I am still editing because I need to change my matrix B to my new matrix, and it's still a 3 by 1. So let's put in these new numbers. So 24, -7, and 35. So I want to go to my home screen, so I'm going to hit second quit. So what I want to put on my home screen are the new numbers that I have stored for matrix A to the -1 and matrix B. So second matrix, use that A, the X to the -1 button, and then second matrix, go down to the B and use that one. And here is your X, Y, and Z, 4, 3, and -1. All right, so this question has to do with the translation of the statement. The first number is 50 more than the sum of the other two numbers. So what I like to do first is locate the word is, or find something that represents equals. So the word is going to be my equals. So look to the left of the word is. It just says the first number. I don't know what it is, so I'm just going to call it X. Then the word is, so that's where my equal came. 50 more than the sum of the other two numbers. So the other two numbers, again, I don't know what those are. I'm just going to say Y plus Z, and then 50 more than that gives me plus 50. Now, you'll notice when you hit the drop down, all the X, Y's, and Z's are on the left side of the equal sign, and the constant is on the right. So I need to move this Y and this Z, in other words, cancel it out on the right, put it on the left. So cancel it here, so all that's left on the right side is the 50. Now, on the left side, none of those are like terms. You can't combine any of those, so you're just going to have X minus Y minus Z equals 50. All right, now we're going to use our knowledge of solving a system of equations in our matrix function of our calculator. So this one, we have triangle A, B, and C. So before we start anything, we need to remind ourselves that when you add up all the angles of a triangle, you're going to have 180 degrees. So that's going to be my first statement. A plus B plus C is going to equal 180. Now, let's look at what it tells us about the angles. It says the measure of angle B is, so let's see what that means. B is 21 more than 3 times the measure of angle A. So how am I going to write that? B is, there's my B equals. Behind the equals, I'm going to have 21 more than 3 times A. So 3 times A, and then 21 more than that. So just like on the last problem, now I need to put all of these letters in their right columns. So I need to subtract the 3A from both sides. So now I've got negative 3A plus B equals, on the right side, I have 21. So when I come and put this over in the system of equations that I'm creating, I know what columns to put these in. I need a negative 3A in the A column, a plus B in the B column. I don't have a C, so I'm just going to leave that column blank, equals 21. So the next statement says the measure of angle C is, so C equals, C is 54 degrees more than A. So it's going to be A, and then add 54. And once again, I need to put the A in the right column, so I'm going to move it to the left side. So now on the left, I can't put those together. I just have negative A plus C equals, on the right, I just have the 54. So when I take this and put it in my system of equations, I'm going to have negative A. I don't have a B for the B column. I do have a C for the C column, equals 54. So now I can use my calculator and create this matrix. So across my first row, all ones. The second row, negative 3, 1. And since I didn't have a C in this C column, I put in a 0. And then negative 1. Again, I don't have a B in the B column, so 0. And my C is a 1. And then your matrix B was the answer side, which is going to be 180, 21, and 54. So let's look at this in our calculator in our matrix function. So second matrix, new problem, so I'm creating new matrices. The matrix A is a 3 by 3. Across my first row, I've got 1, 1, 1. Second row, negative 3, 1, 0. And that bottom row is negative 1, 0, positive 1. So there's your matrix A. Now I need my new matrix B. So second matrix, over to edit, and down to B. And enter your new values. This again is a 3 by 1, 180, 21, and 54. So now I want to do matrix A to the negative 1, matrix B with my new matrices that I have stored. So go to your home screen by second, quit. So second matrix, use that new A that you have in there, your X to the negative 1, and then your new matrix B. So second matrix, down to B, enter, and there's your A, your B, and your C. So A is 21, B is 84, and C is 75. So A was 21, B was 84, and C was 75. All right, this next problem, we are also going to create a matrices by translating these statements into equations. So the first statement says the sum of 3 numbers is 58. So sum means to add. So the sum of 3 numbers is 58. The difference of the largest and the smallest. So if you're finding a difference, you are subtracting. So I'm going to call X the largest, Y the middle, Z the smallest. So the difference between the largest and the smallest is 47, and the sum of the 2 smaller numbers, so if X is the largest, Y and Z are the 2 smaller numbers, if I'm finding the sum of those, I'm going to add them, and they will add, so is 16. So I'm going to create a new matrix A and a new matrix B with the values from this problem. So my first row will be 1, 1, 1. Middle row, 1. Again, there's no Y, so that'll be a 0. Your Z is -1. And the bottom row, there's no X, so it'll be 0. 1 for Y and 1 for Z. And then matrix B, we'll use the numbers from the right side of the equal sign. So 58, 47, and 16. So we'll go to our calculator and create 2 new matrices. So second matrix, I'm creating new, so that's when you go over to edit and edit matrix A. So it is 3 by 3 again, and then I'll go across the top row. So 1, 1, 1. The middle row is 1, 0, -1. And the third row is 0, 1, 1. So there's matrix A. So now I'll create matrix B. So second matrix, again, creating. So go over to edit and down to B, and then enter your matrix. So it's 3 by 1 again, 58, 47, and 16. Now is when you will do matrix A to the -1, matrix B. So get to your home screen. So second, quit. So we want our new matrix. So second matrix A. Then hit your X to the -1 button and second matrix down to B. Enter, and there is your X, Y, and Z. So X is 42, Y is 21, and Z is -5. The 3 numbers from the largest to the smallest. So the largest was the X, so it's 42. Then the next one is 21, and the next one is -5. All right, in this problem, we're going to use matrix work to solve some real-life problems. The produce manager at a market orders 10 pounds of tomatoes, 50 pounds of zucchini, and 30 pounds of onions from a local farmer 1 week. Write a 1 by 3 matrix A that represents the amount of each item ordered. So 1 row, 3 columns. This number is going to represent the tomatoes, then the zucchini, and then the onions. So 10 pounds of tomatoes, 50 pounds of zucchini, and 30 pounds of onions. So when you type this answer in, this number, this down here next to the more key in your toolbox, you'll see that matrix, and you're going to have to tell the matrix, the number of rows. Oh, there it is. So 1 row, can't get it to go. Hang on, let me pause it. Okay, there we go. 1 row by 3 columns, and then enter those numbers into, it's not letting me do it in mine for some reason. Because you'd want to enter the 10, the 50, and the 30. Hold on. Okay, it's not letting me enter it on there for some reason, so we'll just do it on the whiteboard. So that's what matrix A would be. Write the entries. So then after this, the following week, the produce manager increases his order by 10%. Find a matrix B that represents this order. So if we increase matrix A by 10%, so second matrix, let's go over to edit, create a new matrix A. It's a 1 by 3, and then put in our values, 10, 50, and 30. So I want to know what this is. If I increase this 10%, so let's say I want to multiply this new matrix A times 0.1. So second matrix A, second matrix, I want my new A, times 10%, which is 0.1. So what that means, if I increase this by 10%, these orders, I'm increasing the tomatoes by 1, the zucchini by 5, and the onions by 3. So in week 2, the number of pounds of tomatoes increased by 1, so it's going to be 11. Zucchini increased by 5, so it's going to be 55. And the onions increased by 3, so they will be 33. So that's what the entries in B, matrix B, will be. Now, we want to add matrix A plus matrix B and think about what that is going to represent. So I'm just going to do this one by hand. So I'm adding the columns of matrix A to matrix B. So 10 plus 11 gives me 21. 50 plus 55 gives me 105. And 30 plus 33 gives me 63. So that is what A plus B is. So let's think about what that means. What do these numbers in this matrix stand for? It's the order from week 1 and week 2 together. So it's the total produce order for the 2 weeks would be this D answer. And it's going to tell me I didn't fill in all of them because I couldn't do the matrix in the math lab on my smart screen. All right, on this next problem, we are going to create 1 by 5 matrices that are going to go along with the information in this paragraph. It says a 3-ounce serving of roasted skinless chicken breast. So that's going to be this C matrix. It's going to contain 160 calories, so that'll go in the calories, 29 grams of protein, 5 grams of fat, 16 milligrams of calcium, and 61 milligrams of sodium. 1/2 cup of potato salad, so that's going to be our P, contains 160 calories, 4 grams of protein, 10 grams of fat, 21 milligrams of calcium, and 667 milligrams of sodium. And then the broccoli spear. So one broccoli spear contains 50 calories, 4 grams of protein, 2 grams of fat, 80 milligrams of calcium, and 16 milligrams of sodium. So that's what you're going to put in this C, P, and B matrix answers. So I'm actually going to put all of these in my calculator for their matrix. So I'm just going to clear all that out. So creating, so I'm going to put this one in matrix A, potato salad in matrix B, and broccoli spear in matrix C. So creating new matrices. So second matrix, over to edit. Let's see, this has 1 row and 5 columns. So let's enter these numbers. So I have 160, 29, 5, 16, and 61. So there is my chicken matrix. So now I want to make my potato salad matrix. So second matrix again, over to edit. And it's a 1 by 5 matrices also. Oh, whoops, I didn't go down to B. Second matrix, edit. Make sure you go down to B. And again, it's 1 by 5. So enter these numbers. So 160, 4, 10, 21, and 667. And then I'm going to put my broccoli spear in matrix C. So second matrix, still editing. I'm going to make sure I go down to C and enter. It is 1 row, 5 columns, and I'll go straight across. So 50, 4, 2, 80, and 16. So second quit to go to your home screen. So what does it want me to find in part B? It wants me to find what 1 chicken plus 4 potato salads plus 3 broccolis. So C plus 4P plus 3B. So let's go back to our calculator. So 1 chicken. So remember, the chicken is stored in matrix A, and there's just one of those. So second matrix A plus 4, so plus 4, and then the potato salad is stored in matrix B. So second matrix down to B, enter. And then 3 broccoli spears, and remember broccoli spears are in matrix C. So plus 3, second matrix down to C. So 1 chicken, 4 potato salads, 3 broccolis. So this gives me this matrix. 950, 57, 51, 340, and 2,777. So that'll go in the C plus 4P plus 3B matrix. That won't let me, I don't think. Let's see if it'll do it. It doesn't let me type it in for some reason. So, what do the entries in C plus 4P plus 3B represent? Look at this first one. The entries represent the total nutrition value for a 3-ounce piece of chicken. That was 1 serving of the chicken. 4 1/2 cup servings of potato salad. And 3 spears of broccoli, which is exactly what that does represent. All right. The last problems are going to be graphing the inequalities. This first inequality is y is greater than x minus 6. And it wants me to graph this on this graph. So the first thing I want to do is put this in my y equals so that I can get some points on this line. So I'm going to go to my calculator, go to the y equals, clear out whatever's in there, put in the x minus 6. So let's look at what this looks like on a graph. It is going to be a line. So I need 2 points from this line. I'll use 0, -6, and 2, -4. So when we are graphing this, I'm going to click to enlarge the graph. Remember, it was a line. So my first point I'll put at 0, so left and right 0, down 6 for 0, -6. And the second point I'll put to the right 2, down 4 for 2, -4. Now, remember on inequalities. If you do not have the equal to bar, it doesn't say less than or equal to or greater than or equal to, then you're actually going to use a dashed line. So in this example, I need to come over where it's on the line. I need to click the button right below it, right above delete, that turns it to dashed. If you have less than or equal to or greater than or equal to, in other words, if you have that equal to bar, then you are a solid line. But this one doesn't, so that's why it's dashed. Now, the shading rule says if you are greater than the line, you're going to shade above it. So greater than or equal to, shade above. If you are less than or equal to, you're going to shade below the line. And you shade with your paint can. So this one says y is greater than this line. So where is it greater than? I just click any area above the line and save it. So this next one, 2x minus 3y is less than or equal to -9. So before I can put it in my y equals, I do have to solve this for the y. So I'll subtract the 2x from both sides. So now I have -3y is less than or equal to. On the right side, I can't put those terms together, so I just have a 2x minus 9. And then I'll divide by -3 on both sides. So that cancels out that -3. Now, remember when you are dividing both sides of an inequality by a negative number, which is what I just did, the inequality symbol will turn around. So instead of less than, now it's going to be greater than or equal to. The negative over the negative turns into positive 2/3 x. Again, -9 over -3 is positive 3. So that's what I want to put in my y equals to get my 2 points that I will need. So y equals, clear it. So I've got 2 over 3x plus 3. So again, it's going to be another line. I need 2 points. Stay away from all those points that have all those decimals. I'm going to choose the 0, 3, and the 3, 5. Click to enlarge. It is a line. My first point is at 0, 3. So left and right 0, up 3. My next point is at 3, 5. So to the right 3 and then up 5. This one does have the equal to bar. So I want to keep that line solid. And it's greater than or equal to, which means when I shade with my paint can, I'm going to shade above the line. And last one. So on this one, I've got 2 inequalities. Y is greater than or equal to x plus 3. And the other inequality is y is less than or equal to 2 minus x. And this one is multiple choice. And the solution is going to be where the shadings are actually going to overlap. So I'm going to put each of these in a y equals and get an xy chart. So my first one, y equals, and clear it out, x plus 3. Let's just look at it. So there's going to be a line. I need 2 points. So 2, -1, and -1, 2. So I am going to plot those points and draw this line. All right, the first point is at 2, -1. So to the right 2, down 1. The next point is at -1, +2. So to the left 1, up 2. Whoops, I totally made a mistake, which is a good reason to, when you're doing this, I was about to connect those points and look, it's not going to make that line that is in the calculator. So when I go back to my table, this 2 that is showing on where the cursor is in the calculator should have been a -2, -1. So I'm going to erase that. Now, so this is left 2, down 1. And then the other one was correct. Left 1, up 2. Oh, it's still wrong. What am I doing? How about I erase this table and start all over because I got my negatives and everything all messed up. So my XY chart.